Welcome back to Beyond Origins, where we uncover the true stories behind our planet's greatest mysteries. Usually, when we think of a tsunami, we picture the result of an underwater earthquake. Tectonic plate shift, the seafloor buckles, and geologists know exactly how much water that action can mathematically move. But thousands of years ago, an event occurred that broke those known limits. Researchers found massive 700-ton boulders resting completely isolated in the middle of flat, inland plains miles away from the coast. These rocks are massive, the size of multi-story houses. Even Category 5 hurricanes and coastal storm surges lack the required energy to lift something this heavy. Yet the ocean hurled these colossal stones far inland, skipping them across the terrain like pebbles. A typical, standard tsunami rolling in from a deep-sea fault line spreads its kinetic energy out over hundreds of miles. It lacks the highly concentrated brute force required to heave a 700-ton rock up a cliff. It took a single, terrifying wall of water to accomplish this, an 800-foot-tall mega tsunami. To put that height in perspective, a wave that tall would completely swallow the Statue of Liberty from base to torch, 3 times over. So what kind of force on Earth actually has the power to generate an 800-foot wave capable of that kind of localized destruction? The forensic evidence allows us to rule out the seafloor entirely. An underwater earthquake distributes its energy across a massive area, meaning it cannot physically stack water 800 feet high in one specific spot. To find the trigger, geologists had to stop looking down into the deep ocean trenches and start looking up at towering structures above the surface. The true culprit stood thousands of feet above the Atlantic, the Fogo volcano. A standard volcanic eruption slowly pushes magma to the surface. The event at Fogo involved an absolute failure of the mountain's structural integrity. Without warning, an entire massive flank of the volcano completely sheared off and collapsed. Think about the sheer volume of solid rock that makes up Mount Everest. Now, multiply that. The chunk of earth that broke away from Fogo was 10 times the size of Everest. That incomprehensibly large landmass took a sudden, violent plunge directly down into the Atlantic Ocean. When millions of tons of rock hit the ocean, they occupy space previously held by water. Being incompressible, that downward energy translates into a violent upward surge. The spike peaks, folds over, and rolls outward, generating an 800-foot wave. Sudden, massive gravity dropping straight into the ocean provides the localized engine required for nature's most extreme destruction. Those 700-ton inland boulders remain exactly where they landed. They stand as a quiet, permanent monument to one of Earth's most violent days. We build our cities and coastlines assuming a certain level of geographical stability, but events like this highlight how quickly and overwhelmingly the planet can reshape itself. The collapse of Fogo forces us to throw out our conventional, everyday concepts of scale, safety, and risk. Thanks for watching Beyond Origins. If you want to keep exploring the science that shapes our world, make sure to like, subscribe, and leave a comment below. Ultimately, human engineering is incredibly fragile. When tested, nature's sheer brute strength remains the absolute, unparalleled force on Earth.